Hello everyone, my name is Gauri Prakash Ved Pathak. My seminar topic is quantum tunneling, which is also known as potential barrier if energy E is less than phi, means potential. Quantum tunneling is very interesting topic in quantum mechanics. It has wide range of applications. According to classical mechanics, if energy E is less than potential, then there will be always reflection of all particles, for such that if if this is the potential barrier and ball is here having energy E which is less than phi, then ball cannot penetrate this potential barrier or cannot go through above the barrier. But quantum mechanically, if we know in quantum mechanics microscopic particles having, if this is potential barrier and suppose alpha particles or electrons are incident on it, then alpha particles can penetrate through this barrier. According to quantum mechanics, these particles can with small probability tunnel through the other side, thus crossing the barrier. म्हणजे अल्फा पार्टिकलची एनर्जी पोटेन्शियल बॅरियरपेक्षा कमी जरी असेल तरी तो हा बॅरियर जेव्हा ते इन्सिडंट होतात बॅरियरवरती तेव्हा काही प्रमाणात रिफ्लेक्ट होतात आणि काही प्रमाणात त्यांची प्रोबॅबिलिटी असते की पेनिट्रेट होऊन बाहेर पडण्याची. ओके, नाव definition of quantum tunneling or tunneling refers to the quantum mechanical phenomenon where a particle tunnels through a barrier that it classically could not surmount. For example, classically, if ball is here having potential energy E less than phi, cannot go over the barrier or on other side of the barrier. Okay, but quantum mechanically, suppose alpha particles, electrons or any other microscopic particles such as beta particles, gamma particles, etc., or even though light also can transmitted through barrier. Even though energy is less than potential. This picture shows us that this is the potential barrier and classically particle cannot go or transmit through the barrier, but quantum mechanically electron or some alpha particles, or suppose light also incident here, then some part is reflected back, and very few particles are penetrate through or transmitted through the barrier. But classically it is not possible, because it is only reflected back in classical mechanics. This is circuit diagram of quantum tunneling. Here it is the potential barrier when particle of energy E is incident. Here it can penetrate through and some are reflected back. This is the classically forbidden region, because classically it cannot pass, particle cannot pass through the barrier. Okay, now let's see waveform of this quantum mechanically of this function. Suppose psi incident is the wave function, incoming wave function or incident wave function of particle, then some particles are reflected back and very few are go through barriers. So here very few particles are go like this. Here energy is not reduced, पार्टिकलची एनर्जी तर कमी नाही आहे झालेली, फक्त पार्टिकल्स कमी प्रमाणात ट्रान्समिट झाले. देअरफॉर रिड्यूस्ड प्रोबॅबिलिटी बट नॉट रिड्यूस्ड एनर्जी. ओके, पार्टिकल वेव्ह फंक्शन पास्ट द बॅरियर, म्हणजे बॅरियर पास करून जे पार्टिकल आले त्यांचं वेव्ह फंक्शन. ओके, नाव transmission coefficient for a particle tunneling through a single potential barrier. आपल्याला आता पार्टिकल याच्यामधून किती ट्रान्समिट झालेत त्याचं ट्रान्समिशन कोएफिशियंट आपल्याला इथे दिला आहे. टी ऑफ E is equal to e raised to minus 2 integration x1 to x2 dx in square root 2m upon h cross square in bracket v of x minus e, where x1 and x2 are the two classical turning points for the potential barrier. Means here these are the x1 and x2 point of this potential barrier, which for a rectangular barrier this expression simplifies to T of E is equal to e raised to minus 2 in square root 2m upon h cross square v naught minus e in bracket x2 minus x1, which is equivalent to v naught raised to minus x2 minus x1. Now let's see what are the applications of tunneling effect. Tunneling effect provides explanation for following phenomena. The first, the field of emission electron from a cold metallic surface. Cold emission means एखादा कोल्ड मेटॅलिक सरफेस दिले असेल त्याच्यातून इलेक्ट्रॉन्स इमिट होतात. इथे क्वांटम टनलिंग इफेक्ट यूज केला जातो. सेकंड, द इलेक्ट्रिकल breakdown of insulator. Third, reverse breakdown of semiconductor diode. Fourth, the switching action of tunnel diode used in high-speed devices. Fifth, the emission of alpha particles from a radioactive element, in bracket, it is also known as radioactive decay. Sixth, spontaneous mutation of DNA occurs when normal DNA replication takes place after a particular significant proton has defined the odds in quantum tunneling, which is also called quantum biology. म्हणजे बघा, क्वांटम टनलिंग ही कन्सेप्ट नॅनो टेक्नॉलॉजीमध्ये पण यूज केली जाते, क्वांटम बायोलॉजीमध्ये पण यूज केली जाते, इलेक्ट्रॉनिक्समध्ये यूज केली जाते. सेवन्थ, द स्कॅनिंग टनलिंग मायक्रोस्कोप ऑपरेट्स बाय टेकिंग ॲडव्हान्टेज ऑफ रिलेशन बिटवीन क्वांटम टनलिंग विथ डिस्टन्स. स्कॅनिंग टनलिंग मायक्रोस्कोपमध्ये आपण पार्टिकलची साईज फाइंड आउट करण्यासाठी एक निडल यूज केली जाते. त्या निडल थ्रू पार्टिकलची साईज आपण फाइंड आउट करू शकतो. त्याच्यामध्ये आपण पार्टिकलची 3D साईज फाइंड आउट करू शकतो. ते पार्टिकल अगदी नॅनो पार्टिकल्स असतात. तेथे सुद्धा टनलिंग इफेक्ट यूज केला जातो. इन दिस वे क्वांटम टनलिंग इज वन ऑफ द मोस्ट इम्पॉर्टंट फिनॉमिना used in real life applications. Okay, thank you.